Hi everyone. So today we're going to work on factoring and zeros and talk about what are called linear factors of the polynomial. So we have some terms that we're going to do, and we're going to do some things that we've done in the past like factor and use the zero product property to help us find some of the zeros, solutions, roots to a polynomial. And then we're going to work our way up to things that we don't know how to do. Okay? So we're going to start out stuff we know and then kind of work our way up. All right, so we're going to factor and find zeros of a polynomial function, and then we're going to write a polynomial if we know the zeros. So if we know the zeros, what is the polynomial that gave us that? So let's remind ourselves that solutions to a polynomial equation can be called roots, zeros, and I guess solutions. And you know what? Let's put in here x-intercepts. Okay, so we want to remind ourselves those are all words that we're going to hear. You're going to hear a lot more of roots and zeros and solutions than you are x-intercepts because we're not going to be graphing yet. All right, so we're going to write the polynomial in factored form and find the zeros, which means I'm going to solve, okay? All right, so remember our first step with factoring is that we're going to look for a GCF. So x cubed, x squared, and x, I'm going to take on x. So x squared minus 2x minus 15 is equal to 0. All right, now here we're going to use our factoring techniques. Because it's x squared, it's a quadratic now, we can factor, which means that we're going to look for factors of negative 15 that add up to negative 2. The one that comes to mind for me would be negative 5 and positive 3. So choose your method, box, split, distribute, whichever works best for you. Okay, and so we're going to get x minus 5, x plus 3 is equal to 0. Now remember, we had the zero product property. So I'm just going to write that down. Sometimes you might hear it's called the principle. Okay. So basically that means we're going to take each of our factors and set them equal to 0 and solve. So we're going to go x equals 0, x minus 5 equals 0, and x plus 3 equals 0. So hopefully this sounds familiar. It should. And we're going to solve each one. So x equals 0 is already solved. Here we're going to add 5. Here we're going to subtract 3. So our solutions, roots, zeros, is 0, 5, and negative 3. Okay. All right, let's try another one. Okay, so over here, okay, again, I'm looking for the greatest common factor because that's going to make our lives easier. I say x squared. Okay, so that gives us x squared minus x minus 12 is equal to 0. And again, we're going to want to factor because we can factor a quadratic. We know how to do that. Okay, so again, factors of negative 12x that add up to negative 1, negative 4, positive 3. So x minus 4, x plus 3 is equal to 0. So we're going to set all of our factors equal to 0 so we can solve them. Okay, now how do you solve x squared equals 0? Well, for that to be true, I guess x should just be equal to 0. And then x is equal to 4, and x is equal to negative 3. In fact, you know what? I'm going to write this twice. So there's 4 answers, 0, 0, 4, and negative 3. All right. Okay, so try number 3 on your own. Look for a GCF, factor it out, factor it, set your answers equal to 0, and solve. Okay, so here's what I got. I took out a 3x, factored x squared plus 8x plus 16 to x plus 4, set all of them equal to 0, solve, and our solutions are 0, negative 4, and negative 4. Okay, so now that we're going to be able to find the solutions, at least the ones that we can factor, let's talk about these solutions. Okay, so about a real number a and a polynomial. This is what we know is true. That x minus a is a linear factor of the polynomial. Well, yeah, we have like x plus 4, x minus 4, x minus 5, x plus 3. They're linear factors. So that makes a is a 0 of the polynomial. A is also a root or solution of the equation. And B, A is an x-intercept of the graph of the polynomial. So this gives you context to those words that we started out. That 0 is for a polynomial function, root or solution is for an equation, x-intercept is for the graph. Context of the problem. But you're going to hear them interchangeable. Okay, so now that we have these terms as concept, let's talk about those zeros or roots. Those are going to be the two key that we're going to talk about. We're going to be given the roots. How do we write the polynomial? Like, what do we do with it? All right. Okay, so when we write a polynomial from its zeros, we're going to use the x minus a form, where a is the 0. Okay, so we're going to write all of our roots in x minus a form, and then we're going to multiply them together. Okay. All right, so let's try this one. What is the function in standard form? 0 is negative 2, 2, and 3. So we're going to take each one of our zeros, and we're going to write it in x minus a form. So these are all a's. We're going to write 3 of them. X minus plus 2. Okay, let me rewrite that again. Okay, so x minus negative 2, x minus 2, x minus 3. Now, x minus negative 2, we can literally just make that x plus 2, right? Okay, now you don't need to write that x minus negative 2 if we remember that we're always, when we have a negative root, it's always going to be x plus. It's going to work out that way. Now, my suggestion is to take these two together and multiply first. So we can only multiply 2 at a time. So when we multiply this, we get x squared minus 4 because the two x's cancel out. And now I'm going to take x minus 4 and multiply x squared minus 4 and multiply by x minus 3. So again, split, distribute, box, pick your method, FOIL. Always write your answer in order, highest exponent first, descending order. There's our solution. Okay, so let's try this one. All right, so we have 0, 1, and 4. So we're going to go x minus 0, x minus 1, x minus 4. So those are your linear factors, given that the zeros are 0, 1, and 4. Okay, now x minus 0. Now let's really think about that. Isn't it just x? Let's make our lives easier. And again, I'm going to multiply these two together. And again, the order in which we multiply things really doesn't matter. Remember, the commutative property allows us to do that. I'm just saying I'm going to multiply these. It really is your choice. Okay. So I get x squared minus 5x plus 4. I still have this x out in front, which I'm going to distribute. So I get x cubed minus 5x squared plus 4x. All right, let's try another one. Okay, here our solutions are, our zeros are negative 1, 2, and 5. So I'm going to, everybody okay if I write it as x plus 1, x minus 2, x minus 5. Here, one's not necessarily any better than the other, so I'm just going to multiply these two together. Okay, so I'm going to get x squared minus 2x plus 1x minus 2, or x squared minus x minus 2. And then I got to multiply that answer by x minus 5. So we only can do 2 at a time. Now, if we had 4 solutions, you can do 2 and 2 and then multiply those 2 answers together. That's perfectly fine. Okay, so x cubed minus 5x squared minus x squared plus 5x. High risk of making mistakes here. It's 2x plus 10. There we go. All right, why don't you pause the video and try 2 and 4 on your own, see how you do, and make sure you write it in the right form, x minus the root. Okay, let's see what we did here. Okay, so x plus 2, and then x minus 3, x minus 3. And again, I did the minus 3's together, but it really doesn't matter. And I got x to the third minus 4x squared minus 3x plus 18. Okay, so here I have 4, so I did the zeros, which would be x and x, and then x plus 3, x minus 7. So I did the x plus 3 and x minus 7 together, but then the x times x, I multiplied them together as x squared, and then I distributed and got x to the fourth minus 4x cubed minus 21x squared. All right. Okay, so I know we did, again, I feel like we've done like 3 concepts yesterday, the other day, and these are 2 separate concepts. They're all going to mesh together into one big problem, okay, in coming up. So just bear with, all these little tiny things are going to actually add up to one big problem. All right, so we want to make sure that we answered our thing, that we can factor, GCF first, and then factor. I don't think we're going to be doing quadratic formula just yet. Everything should be factorable. Okay, that zero root solution x-intercept are all words for using a, which is our root. And we're going to use x minus a as our form that when we're given the root, we're going to put the polynomial together. All right, let me know if you have any questions, guys. Please stay safe out there, and I'll talk to you again real soon.